Hi guys, in this video I will go through the parts that I'm going to use for the Arduino PCB drawing robot car. Um, in the next video the next video will be about the laser cutter design, and I will be referencing to some of these parts. So this way you'll know which parts I'm talking about. So the first one is the cheap stepper motor. I'm gonna order 2 new ones. This is without the driver board because I found another driver board with the same chip. So by the way, the price for this one stepper motor is $1.71, and of course it's free shipment. All the parts in this video are free shipment. So this is the alternative driver board. Well, the first thing to notice is that it has a marking on the silk screen for ground and VCC, and also the pins are the pin headers are mounted on the bottom side, which will make it much easier to install this board on a breadboard or a prototype board. By the way, let's go back. The price for this one is $0.99. So these are 4 wheels for remote controlled car. I only need 2, but yeah, they come in a pack of 4. It's $9.99 for 4, and of course the car will have more than 2 wheels. It won't be a self-balancing car because that just doesn't make any sense, because it would be too unstable for drawing. I will use small universal wheels, caster wheels, but I haven't figured out yet which one I will use. So that's still an open question. But anyway, these are the main wheels that will be attached to the electric motors. So this part I will use to attach the RC wheels to the shaft of the electric motor. There is actually a picture here that shows how they fit. So an RC wheel typically has an hex opening, as you can see right here. It's this one is 12 millimeter, and there's also a hole in the middle, so that on the outside of the wheel you can fit a screw so that the wheel is locked in place. So the hex part, let's go back here. So the hex part of this adapter fits into the wheel, and it also has a M4 threaded hole to lock the wheel in place. And then the other end, right here, the other end will take the shaft, and there's a set screw included to fix the shaft into the adapter. So that's $2.98 for 2. So for power, I'm planning to use lithium-ion 18650 batteries. These are 2 holders for 4 batteries in total. They also have mounting holes. I'm not sure about the dimensions. So 4 batteries. I'm planning to use 2 pairs in series, so that's 2 times 7.2 volts. And I will step down these 7.2 volts to 5 volts. And so the 2 pairs in parallel will give me more than 5,000 milliamp hours. So this part I will. This part is from the also from the RC world. It's a monitor for the voltage of the batteries, because I mean, imagine that you're flying a drone or a helicopter. You want to know when your batteries are almost empty. So this device will monitor the voltage of each battery and will start beeping. So it has two beepers here. When the voltage goes below a certain threshold that you can configure. So uh, in my case, the four batteries, the positive terminal, the four batteries will be connected to four pins here. And that's $2.68. So this is the buck step down converter that I will use to step down from 7.2 volts to 5.5 volts. Or I'm sorry, 7.2 volts to 5 volts. So the Arduino needs 5 volts, the stepper motor driver needs 5 volts, and the stepper motor itself also needs 5 volts. Now, there may be an issue with this setup because a buck converter, so say that you input 7.2 volts in a buck converter, the maximum output will be less than 7.2 volts. It probably will be something like 6 or even 5.5 volts. So that's a problem, because imagine that the maximum is 5.5 volts and I set the buck converter to 5 volts. So that's a 0.5 volt margin. As the voltage of the battery starts dropping, the buck converter will adjust, so it will still output 5 volts, but the margin will become smaller, so it will drop from 5.5 volts to 5.2 and 5.1 until it's at 5 volts. So at 5 volts, the batteries will probably be at something like 3.5 or 3.4 volts. So once it goes below 5 volts, then the system becomes unstable. It will probably crash. So for that purpose, I'm planning to use this voltage monitor. And of course, hopefully, this buck converter will be able to output more than 5.5 volts. Hopefully, it will be able to output something like 6 volts. Sorry. This laser diode outputs a crosshair, and I'm planning to use this for aligning the robot car with the PCB, because it needs to be in parallel with the PCB. Otherwise, if there is a misalignment, the circuit diagram won't be drawn straight on the PCB. So I'm planning to switch this on when I'm positioning the car before the start of the drawing, and then I will be able to turn it off again. This is the Arduino I'm planning to use. It's an Arduino Uno revision 3 clone, of course, at $4.93. It's not the cheapest Arduino Uno you'll find on eBay, but I've bought from this seller before, and he always has good deals and good parts. So I'm paying a couple of like 30 or 40 cents too much, but yeah, that's not a problem. This is the prototype Arduino shield that I'm planning to use. So I'll have to install male headers either here or here. I'm not sorry, it's probably here. And so these fit onto Arduino, as you can see here. So this board should be sufficient to mount the two Arduino, the two stepper motor drivers and the battery monitor and some headers to connect the batteries and a transistor to control the laser diode, and I'll also have to find a way to mount the somehow mount the voltage or the buck converter. So these are the terminals, the screw terminals I'm planning to use, 10 of them for $1.58. And the spacers for mounting the Arduino, $4.99. That's really expensive in my opinion, but yeah, apparently that's the price you pay. Okay, onto the pen mounting system. So if you look on YouTube, there are many designs for drawing robots. Most of them are more CNC style with X and Y axis. There are a few cars, but yeah, there are various systems for moving the pen up and down. So almost all of them use a servo to raise and lower the pen. And yeah, of course it will be the same for my design, but I'm planning to use 2 linear axes with these linear bearings, and the pen will be mounted in a design that I will make with a laser cutter, so that the mounting is as stable and as so that the pen doesn't move around, I mean. And another requirement that I have is that I want the pen to be exactly in the middle of the robot chassis, so that when the wheels turn in opposite directions, that they turn around the pen. So when the car turns, the pen shouldn't move position. And if you attach the pen directly to a servo, which is a very common design choice, then, I mean, with a laser cutter, you'll be able to come up with a design so that the pen is really in the middle. But yeah, I don't know. It just doesn't appeal to me. I feel that there is still going to be... Wait, the main problem that I see with mounting the pen to the servo, to the moving part of the servo, is vibration, because the servo is very small and the mounting system isn't stable at all. So when the car drives, the point of the pen will move across the PCB and it will vibrate, and I really don't like that. So in order to prevent that from happening, I'm going to decouple the pen mounting system from the servo, and yeah, I'm going to use this linear axis and linear bearings for that purpose. And hopefully in the video on the laser cutter design, this system will become more clear. So occasionally I will shop from AliExpress, especially for these kind of parts, you know, steel parts. They you'll often find better deals on AliExpress. This is a linear axis, 8 millimeters diameter and 20 centimeters long. For my purpose, 10 centimeters would have been more than enough, but I can't find that, at least not for an affordable price. This is $3.92 for one. I'll need 2, and it's of course also with free shipment. So this is the servo I'm planning to use, the MG90. It has a all metal gears. Yeah, it's not very cheap. It's $4.02, and I'm planning to use 2, although 1 will be enough, but I'll also go into the details of that in the video on the laser cutter design. And this is a disc for an adapter really for mounting on the servo head, and I will be able to design parts in the laser cutting design that I can screw onto these 4 threaded holes. It's 99 cents. And that's it. So the next video will be about laser cutting design. Originally I was planning to just, you know, start with a blank page and start designing the parts, but I've been doing laser cutting designs for on and off really for many years now, and it really took me quite some time to find a good workflow and good method, because coming up with these custom shapes is really isn't very easy, as you'll probably see in the upcoming video. Well, actually, it's not hard once you know how to position the various elements of the design. So probably what I will do, instead of starting from a blank page and just start working on the design, is I'll make probably multiple videos that are an introduction into how to design components for a laser cutter, and the various tools that are available for positioning the elements and so on. So I can keep on talking for that for probably a while, but I'll just cut it short here, and the next video will be about the laser cutter design and the tool I'm using, which is probably the tool that everybody is using, and the workflow and so on. So see you next time. Thanks for watching.